Welcome to Video Tutor's Algebra series. In this first lesson, we are going to combine like terms. Now, instead of calling this lesson Combining Like Terms, we can also call it Do Not Combine Unlike Terms, because that's the thing I want you to remember. Do not combine unlike terms. I have 8 problems where I am going to combine like terms. Watch me carefully as I go through these 8 problems. Problem number 1, 9x plus 3x. The first question I ask is, are they like terms? Yes, 9x and 3x are like terms. When I combine like terms, I add the numerical coefficients, or the number next to the x. So 9x plus 3x is 12x. The answer to the first problem, 12x. Problem number 2, 7a plus 4b plus 3a minus 2b plus c. Now the first thing I have to do here is to identify which terms are like. 7a and 3a are like terms. Combining them, I get 10a. 4b and minus 2b are like terms. Combining them, I will get 2b. And this c here is the only c we have. So there's my answer. It's 10a plus 2b plus c. Problem number 3. 5r squared s plus 3rs squared plus 4r squared s. We have to be careful here because r squared s is not the same as rs squared. The 2 terms I combine are here and here. 5r squared s and 4r squared s. Together, they equal 9r squared s. This 3rs squared is the only rs squared we have, so my final answer will be 9r squared s plus 3rs squared. I can't go any further because these 2 terms are not alike. Problem number 4, 7h plus 4h minus 3h. Well, are they all like terms? Yes, they are. Can I combine them? Sure. 7h plus 4h is 11h. If I take away 3h, I get 8h. My answer will be 8h. Problem number 5, 8x squared y plus x squared y. Are these like terms? Yes, they are. Now, how do I add 8x squared y to x squared y? What is the numerical coefficient of x squared y? What I mean is, what number goes right here? It's 1. 8x squared y plus x squared y combined equals 9x squared y. So, the way I look at that problem is it's like saying 8x squared y plus an extra x squared y plus another x squared y. Together they equal 9x squared y. Problem number 6, x squared plus x. Now my first question is, are they like terms? They are not. Be careful of that. You know where a lot of people make mistakes? They combine unlike terms. You cannot combine an x squared with an x. So x squared plus x is equal to x squared plus x. Nothing can be done with that. Our next problem, problem number 7, xy plus x. Now, same thing here. They are not like terms. An xy is not the same as an x. They cannot be combined, and so xy plus x is equal to xy plus x. Remember, do not combine unlike terms. That's where people make mistakes. I want to make sure that you know that. So let's go to the last problem. It says x plus x. Now what does that equal? This is a 1x plus 1x. That's what that is. They are the same thing. X plus x is the same as 1x plus 1x. Together, they equal 2x. So, x plus x equals 2x. There are a lot of people out there who say it equals something else. I don't want you to think that. It equals 2x. Your video tutor workbook has 8 problems where you can combine like terms. Make sure you do not combine unlike terms. Now, if you find it necessary, use your pause and rewind button. It's always important to use these things, so if you don't understand something, we can get to do it over and over again. So now try those problems I have waiting for you. Good luck. In lesson number 2, we are going to solve simple equations. Now this is where the foundation of algebra is. You must know how to solve equations. And the first thing we have to do is get our variable on one side of the equation and all our numbers on the other side of the equation. We do this by using the 4 basic operations: addition, subtraction, multiplication, and division. I have 5 problems here, and I'm going to try to use each of the 4 operations here to solve the equations. Problem number 1. W plus 8 equals 17. That's like saying a number plus 8 equals 17. Now, how do I react to this? When I see a plus sign, I should react with a minus sign. I should subtract 8 from each side of the equal sign. W plus 8 minus 8 will equal W. 17 minus 8 will equal 9. So there we have it. Algebraically, we have solved that equation. We subtracted 8 from each side of the equal sign and got W equals 9. Problem number 2. M minus 11 equals 8. Now when I see that minus sign, how do I react? I react with a plus sign. I should add 11 to each side of the equal sign. M minus 11 plus 11 will equal M. And since I added 11 to the left side of the equation, I must add 11 to the right side of the equation. I get M equals 19. Problem number 3. 4z equals 36. Now, do you know what 4z means? That means 4 times z equals 36. So 4 times a number equals 36. 4 times z divided by 4 will equal z. So the 4's cancel out on the left side. Now, since I divided the left side by 4, I should divide the right side by 4. 36 divided by 4 is equal to 9. Z will equal 9. Now remember, what I do to one side of the equal sign, I should do to the other side of the equal sign. In this case, I divided each side by 4. Problem number 4. 1/3 x equals 12. Now be very careful here. A lot of people make mistakes when they get a fractional coefficient. When 1/3 x equals 12, some people divide by 3. Don't do that. What I want you to do is to multiply each side of the equal sign by 3. Because 3 times 1/3 x will give me that 1x I'm looking for. I have multiplied the left side by 3. Multiplying the right side by 3, 12 times 3, 36. So x will equal 36. Remember, when we have a fractional coefficient or a fraction next to your variable, your x or y, we want to multiply. We want to get 1x or 1y or whatever the coefficient is. Problem number 5, we have a negative number. Negative 2/5 x equals 24. Now, how will I make that negative 2/5 x positive 1x? What you must do is multiply each side of the equal sign by the reciprocal of negative 2/5. And the reciprocal of negative 2/5 is negative 5/2. What happens here, negative 5/2 times negative 2/5 x will give you 1x, and that's the same as x. Multiplying 24 by negative 5/2, the 2 will go into the 24 12 times, and negative 5 times 12 will equal negative 60. So there it is. If negative 2/5 x equals 24, then x equals negative 60. So wrapping this up, I want you to remember, when you see a plus sign, react with a minus sign. When you see a minus sign, react with a plus sign. Know that when you have fractional coefficients that you should multiply to solve for your variable. Now, the Video Tutor Workbook has 5 problems where you can solve simple equations. Try these problems and make sure you understand them before you go any further. Good luck. In lesson number 3, we're going to solve equations where more than one operation is involved. Now, when doing these, we should take care of our addition and subtraction first, and then our multiplication and division. What I mean is, get the numbers on one side of the equal sign, and then try to make your coefficients equal x or y. I have 5 problems here. I want you to watch real close. Problem number 1, 3x minus 7 equals 23. What I want to do is bring that over here. I want to isolate my coefficients. So what I should do is react with a plus 7, and 3x minus 7 plus 7 will equal 3x. The left side of the equal sign has 3x. 23 and 7, 30. So 3x is equal to 30. Dividing each side by 3, I will find that x equals 10. So there we have it. I added 7 to each side and divided each side by 3. X equals 10. I get my x's on one side and my numbers on the other side. That's the key to success. Problem 2. 4x plus 9 equals 53. I subtract 9 from each side of the equal sign. I get 4x on the left. That cancels. And I get 44 on the right. If 4x equals 44, I divide each side by 4. And I get x equal to 11. I subtracted 9 from each side and divided each side by 4 there. Let's look at our next problem. 1/3 x plus 2 equals 7. I should subtract 2 from each side, and I get 1/3 x is equal to 5. Now, what do I do here? I want you to remember, you must multiply each side by 3. What I get is an x on the left, and 5 times 3, 15 on the right. So here I subtracted 2 from each side, and then when I saw the fractional coefficient, I multiplied each side by 3. Let's go to the next problem. 1/5 x minus 6 equals 9. That minus sign should have a plus sign under it. Minus 6 plus 6. They cancel out. We no longer have numbers on the left side of the equal sign. 9 and 6, 15. So if 1/5 of x equals 15, what does x equal? Be careful. What do you do here? You multiply. Multiply each side by 5. So we multiply 1/5 x by 5, and we get x on the left side, and then we multiply 15 by 5. And what I get there is 75. X will equal 75. Problem number 5. 2/5 x plus 3 equals 21. Plus sign, we react with a minus sign. We subtract 3 from each side. That goes away. I get 2/5 x equal to 18. 21 minus 3 is 18. I must multiply each side by the reciprocal of 2/5. That is 5/2. 5/2 times 2/5 x will equal x. 18 times 5/2, well, 2 goes into 18 9 times, and 9 times 5 will equal 45. So there it is. What I want you to remember here is to get your numbers on one side and keep your x's on the other side. Now the problems will be very simple if you keep following this, but if you don't, you're going to run into trouble. Now make sure you also know when to multiply and when to divide. When you have those fractions like 2/5 x, 1/3 x, you have to multiply each side and not divide. Now your video tutor workbook has 5 problems where you can solve equations that contain more than one operation. Make sure that you use the pause and rewind button. It's very important that you understand these simple equations. Now try our problems. Good luck. In lesson number 4, we're going to combine like terms to solve equations. Now this is a combination of the first 3 lessons. You should have your fundamentals down. Know when to get your numbers on one side and your variables on the other side. And also remember, do not combine unlike terms. There are 5 problems here, and I want you to watch me carefully. Problem number 1. 2a plus 2a equals 48. Now, these 2 terms, 2a and 2a, can be combined, and they equal 4a. Combining them and setting them equal to 48, we get 4a equals 48. I now divide each side by 4. and we find that A equals 12. You know, if you wanted to, you could check your answer. You could take that 12 and stick it back up here. 2 times 12 is 24, and 2 times 12 is 24 again. 24 plus 24 does equal 48. That's how you check your answer. You can use that whenever you're unsure of whether you did it right or wrong. Let's go to problem number 2 now. 8x plus 3x plus x equals 60. 8x and 3x is 11x. If you have 11x and you add on another x, what does that equal? That equals 12x. Remember, 11x plus x is the same as 11x plus 1x. So we get 12x on the left side of the equal sign, and we get 60 on the right side of the equal sign. If 12x equals 60, we must divide each side by 12. 12x divided by 12 is x. I'll put that here. And 60 divided by 12 is 5. So x is equal to 5. Problem number 3. 3e minus e plus 4e. 3e minus e is 2e. 2e and 4e is 6e. 6e will equal 90. So if 6e equals 90, we can now divide each side by 6. And 6e divided by 6 is e. And 90 divided by 6 is 15. We find that e is equal to 15. Problem number 4. It's a little bit different. 6x minus x plus 12 equals 52. Now we can't combine all this stuff. Why? Because they are all not like terms. We can take 6x and subtract x. I have no problem with that. I get 5x. But this 12 cannot be combined with 5x. So we'll have 5x plus 12 equal to 52. Subtracting 12 from each side, I get 5x equals 40. And dividing each side by 5, I get x equal to 8. There it is. X equals 8. Problem number 5. 5y plus 7 plus y equals 37. They may be trying to trick you here by sticking that 7 in the middle. Remember, just combine the like terms. The 5y and the y are like terms. They make 6y. That 7 we'll take care of right now. After combining the like terms, we get 6y plus 7 equal to 37. We now subtract 7 from each side and find that 6y equals 30. If 6y equals 30, we divide each side by 6 and find that y is equal to 5. There it is. So remember, combine those like terms. Do not combine unlike terms. Get your x's on one side or your variables on one side and your numbers on the other side. Know when to add, subtract, multiply, and divide. If there's anything you don't understand, go back to those first 3 lessons. And if you do think you're doing a good job, if you think you understand what's going on, I want you to try the problems we have waiting for you in the Video Tutor Workbook. Give those problems a try and see how you do. Good luck. In lesson number 5, we're going to graph solution sets on the number line. Now this is a very simple lesson. What you have to know is what the greater than sign looks like, what the less than sign looks like, what greater than or equal to means, and less than or equal to means. 4 simple problems will be graphed on the number line. Here we go. X is less than 5. If I create my number line, let's see, I'll just write some numbers down like 3, 4, 5, 6. I'll draw a number line, and I'll denote each one this represents the number 3, the number 4, the number 5, the number 6. If I want to represent the set of numbers less than 5, I identify 5 and put a circle here. Now, since this is a less than sign, we use an open circle. Going this way, drawing an arrow, we have all the numbers less than 5. This is the solution set x less than 5, graphed on the number line. Problem number 2. X is greater than or equal to -3. Well, here are my numbers, -5, -4, -3, -2, -1. I just make a number line there. Now, if something is greater than or equal to -3, it's every number to the right of -3. So I identify -3 right here. And look what I do. Since this is greater than or equal to, I fill in the circle. You know how I let my students remember this? If it's less than, I just say less than. If it's greater than or equal to, I go greater than, draw the circle, or equal to. Okay? You got that? You color in the circle if it's greater than or equal to or less than or equal to. And everything that is greater than or equal to -3 is all the numbers to the right of -3, including -3. Greater than or equal to, we got to color in that circle. Problem number 3. X is greater than -7. Now that's only greater than. So what does that tell you about the circle? It's going to be open. Creating my number line, let's say I'll make -10, -9, -8, -7, -6. There's my number line. And starting at -7, I use an open circle and include every number to the right of -7. That's how I graph x greater than -7. Problem number 4. X is less than or equal to 4.5. Let's see, we'll make a number line, 0, 1, 2, 3, 4, 5. And we identify 4.5 as being halfway between 4 and 5. Now, since this is less than or equal to, let's do it again. Less than or equal to. Color it in. And it's going to include everything to the left of 4.5. If it's less than, it's to the left. Less than, left. Greater than, to the right. So there it is. A very simple lesson on how to graph solution sets. Now, take the problems that we have waiting for you in the video tutor workbook. Try those and make sure that you understand this concept. Good luck. In lesson number 6, we're going to cover the 4 basic operations using sign numbers. I'm going to add, subtract, multiply, and divide sign numbers. You have to know this in order to do well in algebra. I have 3 addition problems here and 4 subtraction problems here. To add 2 numbers with different signs, you must go through a 2-step process. I want you to ask yourself 2 questions. Question number 1, will my answer be negative or positive? And question number 2, do I add or do I subtract the absolute values? If you do this, you shouldn't have any problem. Now, you can determine the sign of your answer by seeing which number has the greater absolute value. In this first problem, 7 plus negative 5, well, the 7 has the greater absolute value. What that means is the 7 is bigger than the 5. So my answer will be positive. That's question number 1. Will my answer be negative or positive? I say here, positive. Then I say, do I add or subtract the absolute values? Well, if the signs are the same, you add them. If the signs are different, you subtract them. Well, this 7 is the same as positive 7, so these signs are different. What I have to do is subtract the absolute values. 7 minus 5 is 2. So there it is. 7 plus negative 5 is equal to positive 2. Remember this 2-question process. It makes things a lot easier. Let's look at the second problem. Will my answer be negative or positive? It will be negative because 11 is greater than 6. Do I add or subtract the absolute values? Different signs? I find their difference. I subtract. Negative 11 plus 6 is negative 5. There's my answer. Problem number 3. I ask my 2 questions. First one, will my answer be negative or positive? Well, if they're both negative, the answer will be negative. Do I add or subtract the absolute values? I add them together because the signs are the same. 4 and 10 is 14. So negative 4 plus negative 10 is negative 14. Now, it's time for me to start subtracting. When I subtract, all I do is change the sign of the subtrahend and follow the rules of addition. Now, what does that mean? What that means is I'm going to take the second number, or the number that I'm subtracting from the first number, and change its sign. And I also change that minus sign to a plus sign. Let's take a look. 7 minus 9. Well, I don't like minus signs, so I'm going to make it a plus sign. And in order to make that a plus sign, I have to change this 9 to negative 9. Now I can follow the rules of addition. Question number 1, will my answer be negative or positive? It will be negative. Question number 2, do I add or subtract the absolute values? 9 minus 7, 2. The signs were different, so I subtract. My answer here is negative 2. Problem number 2, negative 5 minus negative 7. You know what? When you subtract a negative, it is the same as adding a positive. So I can take this and change these signs. Negative 5 minus negative 7 is the same as negative 5 plus 7. So adding these 2 numbers together, negative 5 plus 7, my first question answer is positive. My answer will be positive. That number has the greater absolute value. I find their difference. I get positive 2, the answer. Problem number 3, negative 4 minus 2. That's the same as negative 4 plus negative 2. Question number 1, will my answer be negative or positive? It'll be negative. Do I add or subtract the absolute values? I will add them together. The answer, negative 6. Finally, problem number 4. 2 minus negative 6. Now, what did I say? I said subtracting a negative is the same as adding a positive. So 2 minus negative 6 is the same as 2 plus 6. And we all know that. 2 plus 6 is 8. The answer? 8. Now it's time for us to multiply and divide signed numbers. What I want you to remember is a positive times a positive is a positive. A positive times a negative is a negative. A negative times a positive is a negative. And a negative times a negative is a positive. Or better put, if the signs are the same, your answer is positive. If your signs are different, your answer is negative. And that works for division also. So this is going to be pretty easy. Negative 6 times 7. The signs are different. Negative sign. 6 times 7, 42. Negative 42 is the answer. Pretty easy, huh? 5 times negative 3, the answer, negative 15. We know that 5 times 3 is 15, and since the signs are different, your answer is negative. Negative 8 times negative 4 is positive 32. The signs were the same, so my answer was positive. Division. The same rules apply. In this first division problem, the signs are the same, so my answer will be positive. Positive 8 is what I get when I take negative 16 and divide it by negative 2. Next, we have negative 18 divided by 6. My answer will be negative, and 18 divided by 6 is 3. Negative 3 is the answer. And finally, 21 divided by negative 7. Signs are different. My answer is negative. We get negative 3 again. Nice and simple. Using signed numbers is very, very important in algebra. Now, if you don't understand this quick, simple lesson, Video Tutor has a whole tape on signed numbers available. You may want to pick that up. Now, try the problems we have waiting for you. If you need more help with this, I suggest you look into our signed numbers tape. Good luck. In lesson number 7, we're going to evaluate algebraic expressions. Now what this means is we're going to take numbers and plug them into equations. So what we'll do here is we'll read the directions. It says, given x equals 1, y equals negative 2, w equals 0, and z equals 1/2. It says, evaluate each of the following. My first problem says xy minus 2y. Now when I see xy, that means multiply x by y. So if x is 1, I'm going to put a 1 right here, and y is negative 2, I'm going to have to multiply those together, and from that I'm going to have to subtract 2y, or 2 times the value of y, which is negative 2. Now, your order of operations state that you should always multiply and divide before you add and subtract. Remember that. What we have to do here is multiply 1 times negative 2, and that equals negative 2. And here we must multiply 2 times negative 2, and that's negative 4. So, negative 2 minus negative 4 will be my answer. Subtracting a negative is the same as adding a positive. Negative 2 plus 4 is equal to positive 2. This whole expression, xy minus 2y, is equal to positive 2. Problem number 2. W plus 3x minus 4y. W is equal to 0. 3x is equal to 3 times 1. And 4y is equal to 4 times negative 2. So 0 plus 3 0 plus 3 minus negative 8 will be my answer. I almost ignored that 0, but 0 does count for something. Well, 0 and 3 is going to be 3. 3 minus negative 8 is going to be the same as 3 plus 8, and 3 plus 8 is equal to, let me get a nice big 11 there. There it is. So W plus 3x minus 4y is equal to 11. Problem number 3. 4z minus 3wx plus 5xy. Well, 4z is going to equal 4 times 1/2. We'll multiply those together. And then we're going to subtract 3 times 0 times x, which is 1. And to that, we are going to add 5 times 1 times negative 2. 5x is the same as 5 times 1, and y, negative 2. Let's go through the whole thing now. 4 times 1/2 is 2. 3 times 0 times 1. What is that? It's 0. Once we get that 0 in there, everything else is eliminated. They're all multiplied together like that. Then we have 5 times 1 times negative 2, and that's negative 10. So 2 minus 0 is 2, plus negative 10. Question number 1, will my answer be negative or positive? Negative. Do I add or subtract their absolute value? Subtract. This whole expression, 4z minus 3wx plus 5xy, is equal to negative 8. Problem number 4, negative 2xyz plus xy. Well, that negative 2xyz is going to be multiplied all together. That's equal to negative 2, which is already there, times what x is, and that's 1, times what y is, which is negative 2, times what z is, which is 1/2. Now to that we're going to add xy, which is 1 times negative 2. Let's go now. Negative 2 times 1 is negative 2. Negative 2 times negative 2 is positive 4. And positive 4 times 1/2 is 2. That whole thing is equal to 2. And over here we have 1 times negative 2, and that's negative 2. What I get is 2 plus negative 2. And that equals zippity-doo-dah, 0, okay? So 2 plus negative 2 is 0. Our answer to 4 is 0. Problem number 5, 3x plus 5y over 6xy. Well, 3x is going to equal 3 times 1, and 5y is equal to 5 times negative 2. Putting it all over 6xy, which will be 6 times 1 times negative 2. So let's go. 3 times 1 is 3. 5 times negative 2 is negative 10. We're going to have 3 plus negative 10 over 6 times 1, which is 6, times negative 2, which is negative 12. And 3 plus negative 10 over negative 12 is going to equal negative 7 over negative 12. Now, we put this here for a very special reason. Negative 7 over negative 12. Do you know if that's a negative or positive number? Believe it or not, it's a positive number, because a negative divided by a negative is a positive. Negative 7 over negative 12 is equal to positive 7/12. So there it is. 5 problems where we evaluate algebraic expressions. Remember your order of operations. Get your multiplication and division done before you add and subtract. Now try the problems we have waiting for you in the video tutor workbook. Give them a try and see how you do. Good luck. In lesson number 8, we're going to add monomials. Now this is just like our first lesson where we combine like terms. Simply add the coefficients together and keep your rules to negative and positive numbers to add the addition and subtraction of signed numbers straight. 5 problems here, and we're just going to crank them out. You ready? Problem number 1, 5x plus 3x. Added together, this equals 8x. Problem number 2, negative 8z plus 2z. Will my answer be negative or positive? It will be negative. Do I add or subtract the absolute values? The numbers are different, I subtract. And so my answer will be negative 6z. Negative 8z plus 2z is negative 6z. Problem number 3, 7y plus negative 4y. Question number 1, will my answer be negative or positive? Will be positive. Do I add or subtract the absolute values? I subtract them. 7 minus 4 is 3. So combining 7y and negative 4y, we get positive 3y. Going on, problem number 4. 6yz plus yz. Now remember, what is the numerical coefficient of yz? It's 1. So 6yz plus yz, if you had 6yz and you threw on another yz, you get 7yz. There's the answer. 7yz is what I get when I combine those two terms. Problem number 5. X plus negative 5x. That's the same as 1x plus negative 5x. And let's see what we get. Will my answer be negative or positive? Negative. Do I add or subtract the absolute values? You'll have to subtract them. We will get negative 4x as our answer. Problem number 6. Negative x plus negative 10x. Will my answer be negative or positive? It will be negative. Do I add or subtract the numerical coefficients? I add them. The signs were the same, so I add the absolute values. Negative x plus negative 10x is negative 11x. Problem number 7, x plus x squared. Be careful. You've seen this one before. It was in lesson 1. Or maybe it was x squared plus x. Be careful. These are not like terms, and they cannot be combined. So this can't be done, okay? CBD, can't be done, because x plus x squared is equal to x plus x squared. We cannot do anything further with that. Problem number 8, x plus x. I always like this one. I always give it over and over again. Remember, x plus x is 2x. It is not x squared. X plus x is 2x because that's the same as 1x plus 1x, and 1 is 2. 2x is what we get. Problem number 9. 4x squared plus negative x squared. That's the same as negative 1x squared. So combining these, I will get, let's see, my answer will be positive. 4 minus 1 is 3, and I will get 3x squared. 4x squared plus negative x squared is 3x squared. And finally, 5xyz plus 6xy. Now, these are not like terms. You can't add an xyz to an xy. They're trying to fool you here. So 5xyz plus 6xy equals 5xyz plus 6xy. There it is. So adding monomials is combining like terms. Make sure you do not combine unlike terms. Now, the Video Tutor Workbook has 10 problems where you can add monomials. I want you to try those problems. Make sure you do a good job. Good luck. In lesson number 9, we're now going to subtract monomials. Now, as we go through this Algebra 1 program, you're going to see that I don't really like to subtract. I like to add the opposite. I like to change the sign of the bottom term and follow the rules of addition. This makes things so much easier. When I have this subtraction problem where it says negative 5x, subtract 2x from negative 5x, what I should do is just change the sign of the bottom term, make that 2x a negative 2x, and follow the rules of addition. I will get minus 7x. The signs are the same, and I add their absolute values. Problem number 2. Subtract negative 4x from 0. Change the sign of the bottom term, follow the rules of addition. 0 and 4x is 4x. The answer, positive 4x. Problem number 3, subtracting negative 5mn from negative 7mn. I change the sign of the bottom term and follow the rules of addition. I get minus 2mn. My answer, negative, subtract, and keep the mn. Negative 7mn minus negative 5mn is negative 2mn. Problem number 4. From negative 4x squared, take negative 5x squared. Now, it's very important to read these carefully. From this expression, negative 4x squared, we must subtract negative 5x squared. So I'm subtracting the bottom term from the top. What do? I change the sign of the bottom term and follow the rules of addition. I will get positive 1x squared. And that's the same as regular old x squared. There we have it. Problem number 5. How much larger than 5a squared b is negative 7a squared b? So what we have to do there is, it's hard to think about this. So like if we substituted numbers, if we said how much larger than 5 is 10, you'd want to take that and subtract that. If we had 5 is 10, you'd take 10 minus 5 to find it. So we'd have to take the same thing here. Negative 7a squared b, we're going to subtract 5a squared b. Change the sign of the bottom term and follow the rules of addition. My answer will be negative. I add their absolute value, and I get negative 12a squared b. So there it is. When subtracting monomials, I want you to change the sign of the bottom term and follow the rules of addition. Now, your Video Tutor Workbook has 5 problems where you can subtract monomials. I want you to give those problems a try and see how you do. Good luck. In lesson number 10, we're going to multiply monomials.
Now, when we multiply monomials, we simply add the exponents to like variables. In other words, let's look at problem number 1. X to the 6th times x cubed. Now, x to the 6th is the same as x times x times x times x times x times x. 6 x's. 1, 2, 3, 4, 5, 6. And x cubed is the same as x times x times x. So if we're going to multiply x to the 6th times x to the 3rd, we're going to get x to the 9th power. The simpler way of doing it is simply adding the exponents. Problem number 2, we have more than one variable involved. We have numbers, we have y's, and we have z's. What I want you to do here is multiply your numbers by your numbers, your y's by your y's, and your z's by your z's. 2 times 3, 6. Y times y squared is y cubed. And z just hangs on the end there. So 2yz times 3y squared is equal to 6y cubed z. Fairly simple, huh? Let's go to problem number 3. Here we're going to do the same thing. Multiply our numbers by numbers by numbers, our x's by x's, and our y's by y's. We have negative 2x times x squared y times y. Well, the numerical coefficients in the second and third term are 1. So we have negative 2 times 1, that's negative 2, times 1 again, remains negative 2. Looking at the x's, we have x times x squared, and that's x cubed. And looking at the y's, we have y times y, just in the second and third expression. And so the entire thing is equal to negative 2x cubed y squared. Not too bad, huh? Problem number 4. Now, we have to be careful here because they tell you to square negative 2ab. So this problem, which is negative 3a squared b times negative 2ab squared times 5b to the 4th, let's see what we get. This first expression remains the same, negative 3a squared b. We have to exponentiate or square this before we do any multiplying. So negative 2ab times negative 2ab is 4a squared b squared. It's positive 4. Negative times a negative is a positive. And our last expression is 5b to the 4th. That stays there also. So now I'm ready to go. Numbers by numbers. Negative 3 times 4 is negative 12. And negative 12 times 5 is negative 60. Our a's, we get a squared times a squared, and that's a to the 4th. And our b's, we get b times b squared, which is b cubed, times b to the 4th, which is b to the 7th power. I did the numbers by numbers, a's by a's, and b's by b's. My result, negative 60, a to the 4th, b to the 7th. Problem number 5. We have 2/3 t squared times r s squared t times 6r squared s. Well, let's see. 2/3 times 6 is 4. Now let's take a look at the r's. We have an r here and an r here. R times r squared is r to the 3rd power. S's, we have an s squared times s, that's s to the 3rd power. And t's, t squared times the t here is t to the 3rd power. My answer, 4, r cubed, s cubed, t cubed. Numbers first, then my r's, then my s's, then my t's. Very easy. Finally, problem number 6. Negative 1/5 u times the quantity u to the 5th v to the 5th times the quantity negative 5 uv cubed. Now let's take care of the numbers. We have negative 1/5 times negative 5. That's positive 1. Now when dealing with monomials, we don't need that numerical coefficient of 1. So negative 1/5 times negative 5, I guess I'll just put the 1 here. And I'll show you later we don't really need it. The u's, we have u times u to the 5th, that is u to the 6th power, times u again, that is u to the 7th power. V's, we have v to the 5th times v cubed, and that is v to the 8th power. My answer, 1u to the 7th, v to the 8th, and that's the same as u to the 7th, v to the 8th. There we have it. So there it is, multiplying monomials. When doing it, multiply your numbers by your numbers, and then your variables by your variables. Make sure when you multiply two terms together that you add the exponents. Now try the problems we have waiting for you in the Video Tutor Workbook. Make sure that you understand this concept. Good luck. In lesson number 11, we're going to divide monomials. Now, when we multiplied monomials, we added the exponents. What do you think we do when we divide monomials? We subtract the exponents. Let's take a look at some problems here. X to the 8th divided by x. Now, when we see that x, I want you to remember that that x is the same as x to the 1st power. X to the 8th divided by x to the 1st, well, I'm going to take 8, subtract 1. My answer will be x to the 7th power. Very simple. Now, the same thing occurs in division. When we look at problem number 2, we take care of the numbers, then the a's, then the b's. Negative 12ab divided by 6a. Now, that's the same thing as negative 12ab over 6a. They're the same thing. Negative 12 divided by 6 is negative 2. So we'd have a negative 2 here. The a here can cancel with the a there. And that leaves negative 2b. Negative 2b is our answer. I find the fractional way, or making these division problems fractions in algebra are always the easiest way to do it because it's very simple to cancel things. Problem number 3, negative 27xyz divided by 9xz. 9 goes into negative 27, negative 3 times. That x and that x cancel out. That z and that z cancel out. That leaves me with negative 3y. That's the answer. Negative 3y. Nice and simple, huh? Problem number 4. Well, we may get a little difficult here. Nothing drastic. 81 c to the 9th d to the 7th divided by negative 3c to the 5th d to the 6th. Now, 81 divided by negative 3 is negative 27. C to the 9th over C to the 5th, remember I said we subtract exponents. If I cross out that C to the 5th, that C to the 9th becomes C to the 4th because 9 minus 5 is 4. D to the 7th over D to the 6th, well, we cross out the D to the 6th, and if we take D to the 6th out of D to the 7th, that leaves us with D, or D to the 1st power. My entire answer, therefore, is negative 27, C to the 4th, D. Finally, problem number 5. Negative 49, C to the 4th, B cubed over 7, C squared, B squared. The 7 goes into negative 49, negative 7 times. C squared goes into C to the 4th. leaving c squared, or 4 minus 2 is 2. And b cubed over b squared, that'll leave a b, or b to the first on top. My answer, negative 7, c squared, b. There it is. When dividing monomials, you subtract the exponents of like variables. So it's a very simple process. It's just like multiplication. Numbers by numbers, variables by variables. Now your video tutor workbook has some problems where you can divide monomials. I want you to give those problems a try and see how you do. Good luck. In lesson number 12, we are now going to add and subtract polynomials. The concept remains the same, except now I'm going to add my m's to my m's and my n's to my n's. Remember, never to combine unlike terms. What we have in problem number 1 is the polynomial 3m plus 2n. We want to add 5m minus 3n to that. Adding my m's to my m's, I will get 8m. Positive 2n and negative 3n is negative n. So I get 8m minus n as my answer. Not too difficult. Don't go any further than 8m minus n. That is your answer. Problem number 2 says rearrange and add 3x plus 5y minus z. To that we want to add negative 7y plus 6z minus 4x. Well, I'm just going to put this term underneath that term, and we're going to add them together. That minus 7y, I'm going to put right under this y here. That 6z will go right here. And that minus 4x right there. My x's are under my x's, my y's under my y's, and my z's are under my z's. I can now get rid of this. And now I add. 3x and negative 4x is minus x. Positive 5y and negative 7y is negative 2y. And minus z plus 6z is positive 5z. My answer, minus x minus 2y plus 5z. Never combine unlike terms. That's the whole key. Problem number 3. Negative 3a squared plus 6b squared. And to that we are going to add negative 5a squared minus 7b squared. Well, two negatives. My answer will be negative. At least my a squares will be. I add the absolute values. I get minus 8a squared. Here, let's see, my b squareds, I'm going to get a minus sign. I subtract the absolute values, so I'm going to get minus a b squared. My answer, minus 8a squared minus b squared. In problem number 4, they want me to subtract. Now remember what I always say. Instead of subtracting, I want to add the opposite. So I change the sign of the bottom terms all the way through. This 3ab plus 9cd now becomes a minus 3ab plus a minus 9cd. Together, 2ab and minus 3ab is minus ab. And minus 3cd and minus 9cd is minus 12cd. My answer is minus AB minus 12cd. Problem number 5. 9xy minus 7ab. We're going to subtract from that 3xy minus 5cd. Now, we have no other AB here and no other CD there simply because we don't have them. Okay, the like terms are xy's. The unlike terms are a, b, and c, d's. Changing the sign of the bottom term, I will get 6xy. That minus 7ab comes straight down, and that new plus 5cd comes straight down also. The answer, 6xy minus 7ab plus 5cd. There it is, adding and subtracting polynomials. Do not combine unlike terms. And now, try the problems that we have waiting for you in the Video Tutor Workbook. Make sure you do a good job with them. Good luck. In lesson number 13, we're going to divide a polynomial by a binomial. Now, there's a list of rules that I want you to remember when doing this. Match the first term by multiplying. Draw the line, change the sign, add. Match the first term by multiplying. Draw the line, change the sign, add. I want you to repeat that to yourself over and over again, because it's funny. When we divide a polynomial by a binomial, we never divide. We multiply and we add. Remember that. Let's look at some of the problems we have. X squared plus 7x plus 10 divided by x plus 5. What we're going to have is x plus 5 going into x squared plus 7x plus 10. Match the first term by multiplying. What times x is this first term, x squared? The answer is x. X times x, x squared. And then we take this x and multiply it by 5. X times 5 is 5x. I draw the line, change the signs of the bottom term. That's what I mean by draw the line, change the sign. And then I add. The x squareds cancel out, and I get 2x plus 10. I now repeat the process. Match the first term by multiplying. What times x is 2x? The answer is 2. 2 times x, 2x. And 2 times 5 is 10. Draw the line, change the sign, add, and I get 0 as the answer. Problem number 2. 3x squared plus 10x plus 3 divided by 3x plus 1. Let me write that out. I'm going to divide it by 3x plus 1. Now remember, match the first term by multiplying. What times 3x is 3x squared? The answer is x. X times 3x, 3x squared, and x times 1 is x. Draw the line, change the sign, and add. The 3x squareds cancel out. 10x and negative x is 9x, and we bring down the 3. So we have 9x plus 3. What times 3x is 9x? The answer is 3. 3 times 3x is 9x, and 3 times 1 is 3. Draw the line, change the sign, and add. That gives me a remainder of 0. And so my answer is x plus 3. Problem number 3. X cubed plus 2x squared minus 5x plus 12 divided by x plus 4. Setting this up, we make sure that we follow the same exact rules. Now let's see what I get here. Got one extra term this time. Now, we match the first term by multiplying. What times x is x cubed? The answer is x squared. X squared times x, x cubed. X squared times 4 is 4x squared. I draw the line, change the sign, and add. we get minus 2x squared minus 5x plus 12. Match the first term by multiplying. What times x is minus 2x squared? The answer, minus 2x. So we get minus 2x times x, minus 2x squared, and minus 2x times 4 is minus 8x. Draw the line, change the sign, and add. I get 3x plus 12 down here. Match the first term by multiplying. What times x is 3x? 3. 3 times x, 3x, and 3 times 4 is 12. We draw the line, change the sign, add, and everything cancels out here. So x cubed plus 2x squared minus 5x plus 12 divided by x plus 4 equals x squared minus 2x plus 3. Next problem. 18k squared minus 3kr minus 10r squared. Let me write that down. 18k squared minus 3kr minus 10r squared. We divide that by 6k minus 5r. And let me go through it now. What times 6k is 18k squared? The answer, 3k. 3k times 6k, 18k squared. 3k times minus 5r is minus 15kr. Draw the line, change the sign, and add. I get 12kr minus 10r squared. Now, what times 6k is 12kr? The answer, 2r. 2r times 6k is 12kr, and 2r times minus 5r is minus 10r squared. Draw the line, change the sign, add, I get 0. So there it is. 18k squared minus 3kr minus 10r squared divided by 6k minus 5r equals 3k plus 2r. Our last problem. X cubed minus 3 divided by x squared plus x minus 3. Now, you know where the key to this problem is? The key to this problem is correctly writing it down. I want you to watch what I do. See, this is okay. The x squared plus x minus 3. But this x cubed minus 3, we have to stick some zeros in. Something like, it's like a dummy variable. What we do is we take the x cubed. Now, since we have no x squareds in there, we're going to put 0x squared in, and no x's, so we'll put 0x in also, and then a minus 3. Now, we know that 0x squared and 0x equals 0, so it doesn't matter that we throw those in there. But you'll see where we're going to need them. We're going to need to line up terms right here underneath these two expressions, 0x squared and 0x. Now watch what I do. Match the first term by multiplying. What times x squared is x cubed? The answer is x. X times x squared, x cubed. X times x, x squared. And x times minus 3 is minus 3x. Draw the line, change the sign, and add. We get minus x squared plus 3x minus 3. Same thing. Match the first term by multiplying. What times x squared is minus x squared? It's minus 1. Putting minus 1 there, we get minus 1 times x squared minus x squared. Minus 1 times x is minus x. And minus 1 times minus 3 is plus 3. Draw the line, change the sign, and add. That cancels out. We get 3x and x, which is 4x. And we get negative 3 and negative 3, which is minus 6. So our answer is x minus 1 with a remainder of 4x minus 6, or x minus 1 plus 4x minus 6 over this expression here, x squared plus x minus 3. So there it is. Match the first term by multiplying. Draw the line, change the sign, add. Match the first term by multiplying. Draw the line, change the sign, add. Try the problems we have waiting for you in the video tutor workbook. Good luck. In lesson number 14, we're going to solve equations containing parentheses. I have 5 problems here, and I'm going to work right through them. What I have to remember is to know when to multiply and to know when to distribute a minus sign. Problem number 1. 2 times the quantity x plus 3 equals 18. Now, what this means is we're going to take 2 and multiply it by x plus 3. I have to multiply 2 by x and 2 by 3. So 2 times x is 2x. 2 times 3 is 6. This 2 times the quantity x plus 3 is the same as 2x plus 6. And that 2x plus 6 is equal to 18. Subtracting 6 from each side, we're going to get 2x equal to 12. And dividing each side by 2, we'll get x equal to 6. Not too bad. Problem number 2. 5 plus 3 times the quantity x minus 2 equals 5. That's the same as 5 plus 3x minus 6 equals 5. I multiplied the 3 by x and the 3 by minus 2. Combining the like terms, which in this case are the numbers, I'm going to get 3x minus 1 equals 5. Adding 1 to each side, I get 3x equals 6. And if 3x equals 6, x is equal to 2. Problem number 3. Now this problem's a little different because we have a minus sign. And when we have a minus sign outside of parentheses, we have to distribute that minus sign throughout the entire term. So here we go. 2x minus the quantity x plus 2 equals 6. We'll get 2x. Now to take these parentheses off, we're going to make that x a minus x and that 2 a minus 2 and set that equal to 6. We'll get 2x minus x minus 2 equals 6. Combining, we get x minus 2 equals 6. Adding 2 to each side, we get x equals 8. And that is our answer. Distributing the minus sign. We have to do it again in problem number 4. The quantity 3x minus 1 minus the quantity 2x plus 3 equals 6. That's the same as 3x minus 1. That stays the same. There's no minus sign outside here. Minus 2x minus 3 equals 6. Combining like terms, we'll get x, we'll get minus 4, we get equal to 6. And if x minus 4 equals 6, we add 4 to each side and get x equal 10. Problem number 5. Now in this problem, we have 2 sets of parentheses. What we should do is start from the inside and work our way to the outside. Since there's a plus sign outside of this parentheses, we're going to just leave it alone. You know, when you have a plus sign outside these things, you can just pull the parentheses off and just leave them as they are. Leave that 4x a 4x and leave that 1 a 1. The square parentheses is what we're going to deal with next. Let's combine the like terms in here. X and 4x is 5x. 1 and 3 is 4. So we're going to have a 5x plus 4 inside the square parentheses. That's going to equal 6. And we can't forget the beginning of the expression. So now we're going to take this minus sign and distribute it through the entire expression 5x plus 4. We'll get 3x minus 5x minus 4 equals 6. And again, we combine like terms. We're going to get minus 2x minus 4 equals 6. Adding 4 to each side, we're going to get minus 2x equals 10. Dividing each side by minus 2, we will get x equal to minus 5. There it is. Solving equations containing parentheses. When you have a plus sign, you can leave the inside expression alone. But when you have a minus sign, make sure you distribute that minus sign throughout the entire expression. Now try the problems we have waiting for you in the video tutor workbook. Give our problems a try and see how you do. Good luck. In lesson number 15, we're going to solve absolute value equations. Now, in this lesson, I want you to remember that we'll almost always have two answers. See, you have to know how the absolute value function works. When I have a problem like this, the absolute value of x equals 4, there's not one answer that can satisfy this, but two answers. If x were equal to 4, you would find the absolute value of 4 to be 4. And if x equaled negative 4, you would find the absolute value of negative 4 to be 4. So every single time we have an absolute value problem, we must set the problem equal to the positive and negative number found on the right side of the equal sign. Let me show you how a few more problems are done. Here's one. X plus 1, the absolute value of x plus 1 equals 3. Well, my two equations can be x plus 1 equals 3 and x plus 1 equals negative 3. Solving both of those, they're nice simple equations, we'll get x equal 2 here. Subtracting 1 and subtracting 1, we'll get x equal negative 4 here. You'll get a solution set of 2 and negative 4. Two answers is what we get. Let's look at problem 3. The negative absolute value of x plus 2 equals 2. Well, if I were to do that, let's see, I could change that to a plus and that to a minus. But you know what? This still can't work. We can't put any number inside the absolute value sign and have it equal a negative number. It just doesn't work. The empty set is the answer here. There is no solution. Problem number 4. The absolute value of x plus 3 plus 1 equals 8. Subtracting 1 from each side, we get the absolute value of x plus 3 equal to 7. Now, once we get it down to that, we can set x plus 3 equal to 7 and x plus 3 equal to negative 7, the opposite of 7. Finding x, we will find it to be x equal to 4. And let's see, we can also find x equal to negative 10. The solution, 4 and negative 10. Our fifth problem. 2 times the absolute value of x plus 1 equals 6. Divide by 2, and we get the absolute value of x plus 1 equal to 3. And that's the same as x plus 1 equaling 3 and x plus 1 equaling negative 3. Subtracting 1, we get x equals 2. And subtracting 1, we'll get x equal negative 4. The solution set will be 2 and negative 4. So there it is. As you can see, when we solve these absolute value equations, we often get 2 answers. So now, try the problems that we have waiting for you in the Video Tutor Workbook. Make sure you do a good job with them. Good luck. In lesson number 16, we are going to solve for x when more than one variable is involved. Now, the thing to remember here is that we have to solve for x. We know we have our answer when we have x equals. And we have to use the rules of addition, subtraction, multiplication, and division. So, our first problem says 7x equals b. Now, if I want to solve for x, I would have to divide the left and right side by 7. 7x divided by 7 is x, and b divided by 7, well, it's just that. It's b over 7. So we knew that 7x equaled b, but we want to find x, and x is equal to b over 7. Problem number 2, rx equals 3. Divide the left side by r, divide the right side by r. We'll get x equals 3 over r. Not too tough, huh? We have found the value of x. X equals 3 over r. Problem number 3. 9 plus x equals c. We're going to have to take away the 9 here and take away 9 here to find x. X therefore equals c minus 9. Problem number 4. 5 minus x equals h. Now we have 2 options here. We can bring the 5 over here, but that's going to leave us with a minus x. Or we can add x to each side. I think I'll do that. And I'm also going to subtract h from each side. And I will find that that cancels out and that cancels out, and I will get minus h plus 5 equals x. And if minus h plus 5 equals x, that's the same as x equaling minus h plus 5. Or even x equal to 5 minus h. As long as you keep the proper sign in front of your variable, you can switch them around. Minus h plus 5 is the same as 5 minus h. Problem number 5. We get a little more detailed here. A equals bx plus 6. Subtracting 6 from each side, we will find that a minus 6 is equal to bx. We now divide each side by b, and we find that x is equal to, I'm going to go over here, it's going to equal a minus 6 over b. That's the important thing. X equals. Notice every single one of my answers starts with x equals. Let's go to our final problem. RSX minus RS squared equals 0. Adding RS squared to each side, I will find that RSX equals rs squared. Now I must divide each side by rs, and I will find that x is equal to, let's see, the r's cancel and s goes into s squared, leaving s to the first power. What do you know? X is equal to s. That's all it equals. So now there it is. When we are solving for x, we want our answer to start with x equals. Now try the problems that we have waiting for you in the video tutor workbook. Give our problems a try and see how you do. Good luck. In lesson number 17, we are going to solve inequalities. Now, what are inequalities? Those are the equations with less than signs and greater than signs. They're very much like regular equations, except when dealing with negative numbers. Now, here are some problems. Let's get started on them. 2a minus 2 is less than 8. If we add 2 to each side, we're going to get 2a less than 10. And dividing each side by 2, we're going to get a less than 5. There's our answer, just like a regular equation. You can graph that on the number line. And if you don't understand how to do that, refer back to that lesson where we do graph solution sets on a number line. Problem number 2. Negative 5z is less than 25. Now, the regular way to solve this is to divide each side by negative 5. I have no problem with that. Negative 5z divided by negative 5 is z. 25 divided by negative 5 is negative 5. But what happens? This less than sign turns to a greater than sign. Whenever we divide by a negative number, we change the sign, and we change the direction of the sign. So less than signs become greater than signs, and greater than signs become less than signs. I've got another problem here, and I just want to run through that one more time. Very simple. Negative 7x is greater than negative 21. Dividing each side by negative 7, I will get x, because the negative 7's cancel. Here I will get negative 21 divided by negative 7. That's positive 3. But since I divided by that negative 7, the greater than sign becomes a less than sign. So there's a rule that we have to remember. Whenever dividing by a negative number, when doing an inequality, we change the direction of the sign. The less than sign becomes greater than, and the greater than sign becomes less than. Here's another problem. 3b plus 15 is greater than 9. We subtract 15 from each side, and we get 3b is greater than negative 6. Dividing each side by 3, we get b greater than negative 2. Now, why didn't I change the sign there? That's what I want to ask you. I divided by a positive number, so there's no reason to change the sign. Just because this is negative doesn't mean we change the sign. It's the numerical coefficient of your variable, and that was positive, so we don't change the sign. Problem number 4. Negative 2n plus 6 is greater than negative 4. We got to subtract 6 from each side, and we'll get negative 2n is greater than negative 10. Now I divide each side by negative 2. And what happens? N is less than 5. Over to problem number 5. Negative 3s plus 6 is greater than s minus 30. Subtracting s from each side, and subtracting 6 from each side, we get minus 4s is greater than minus 36. That and that cancel. So minus 3s and minus s is minus 4s, and minus 30 and minus 6 is minus 36. Dividing each side by minus 4, we will get s less than 9. Why is it a less than sign? Because when dividing by a negative number, we change the greater than sign to a less than sign. That is the simple lesson I wanted to teach you here. So now try the problems we have waiting for you in the video tutor workbook. Make sure you do a good job with them. Good luck.